welcome everyone, and get ready for a fun next 30 minutes. I'm Oscar Martinez. I am the head of Big Data, Cloud, and Advanced Analytics in ClearPeaks. And together with me, I have the pleasure to have Alex Maillo, one of the data engineers in my team. Today, as Nate mentioned, we're going to discuss basically how we use Dremio and Power BI to optimize the way that one of our customers is managing survey data. We're going to have a little introduction to ClearPeaks, to us, and then we're going to jump right into the use case with a little reminder, refresher of some couple of Dremio concepts, which I'm sure most of the audience will be aware of. And then I'm going to give it to Alex, and he will basically explain the rest of the use case. And then, the meat of the talk will be covered by Alex. And then we will have a wrap-up conclusions, and then Q&A where we will answer questions that you might write in the Q&A section. Okay, ClearPeaks, we are basically consultancy firm that is specialized in everything about data, from the typical BI to big data and cloud and advanced analytics. And we also have a bunch of developers that produce custom applications for the custom experience of our customers. We cover all the planet. Our headquarters is in Barcelona, and we also have a few offices around the globe. But yeah, we are doing everything about data for over 23 years already. The project that we have been working is it's basically a massive survey exploration, and basically it's a customer that their job is to collect and to execute surveys, ask questions to people basically around Europe, and they are collecting all the information. Every survey have around between 200, 400 questions, and it's asked to thousands of people. So you can imagine that the amount of data that this is collecting is relatively large. Until now, the customer was storing the data into a classical relational database management system, be it Oracle, Postgres, MySQL, either of these. And they were using the BI extracts, the extract features of a certain BI tool, okay? And they were loading the entire data set into extracts, what was occupying a lot of space. And the more the data set was growing, they started to have concerns with the cost of the server and the associated cost of the license. Okay, so at some point they came to us and they asked for advice, because by now when they came to us, it was 1 billion of rows, and now it's already 2 billion of rows. Basically, what we proposed was to decouple the storage and compute. So basically, all the survey data is going to be stored in a data lake, and then basically we're going to have a very cool query engine like Dremio, basically, to do all the heavy compute to execute the queries. And the weight, the workload that the BI tool has to handle is very, very light. There is no need to use BI extras. It can be a very small server. And basically, this means a very cost-effective solution. The solution itself is cloud agnostic because it can run anywhere, not only in the cloud, it can also run on premise. And basically, what we did for today was to generate a dummy data set with 1 billion rows, and that's the one that Alex will show, and we will talk about this dummy data set. So this is the old architecture. Answers of the survey data is loaded into a relational database management system. Then we have the BI tool that is getting the extracts and basically also acting as a compute platform, and it produce a dashboard. Our solution, as you can anticipate, is basically we store the data in a bunch of CSVs or parquets, whatever, in Amazon S3. Then we have Dremio, that is basically the SQL engine. In Dremio, we are going to make use of the reflections, which I will cover in just a second. And then basically, we demonstrated the capability with Power BI because we just love Power BI, but it could do the same with other BI tools. But today, we decided to do this demonstration with Power BI. So now, before I give it to Alex, just a little refresher on reflection. Reflections in Dremio, I'm sure most of you know it. It's the main feature to accelerate queries. It's something that you build on top of datasets. The dataset can be a view of the data, or can be an anchor dataset. You can program Dremio to automate to update them automatically. And basically, Dremio also suggests creation of certain reflections when certain queries are run. There are Dremio recommends a way to organize the different data in different layers, and we have totally followed this recommendation, which is this semantic layer, from the physical layer to staging, business, and application layer. So basically, there are two types of reflections. The raw reflections, it's basically a way to organize and partition the data, but the data is left as is, kind of, okay? You can have some little transformations, but the data is basically here. What you get is to use a more efficient format, like Parquet or Iceberg, or some table format or file format that is more efficient. And basically, Dremio does that for you if your data is not already in that format. If your data is already on an Iceberg table, probably a raw reflection won't give a lot, but if it's in CSVs, like it was our case, raw reflection will speed up a lot. The second type of reflection is the aggregation reflection, which is kind of a cube, okay? So for queries that do group bys or wheres or this kind of filtering, then basically you can use like a pre-computed cube that is totally automatically managed by Dremio, and then basically your queries will be much faster because they will touch much less data. Our data set consists basically of one fact table that is very, very fat with 1 billion rows, and then a bunch of little dimension tables that cover the demographic data, like the gender, like the social level, like the studies, or the if it's a woman or a male, and also the type of questions, the type of the questions and the answers. And the big fact table is basically the combination of all the answers. And with that, I will give it to Alex. So Alex, all yours.
Yeah, thanks, Oscar, for the introduction. It's Alex speaking now, and I'm going to walk you through the creation of reflections for getting the most out of Dremio when it comes to handling. Am I on mute? Yeah, no. You can hear me.
Now you're okay. Now you're okay.
Okay. Let's start with the deep dive into reflections. The first thing we do when starting a project with Dremio is a one-to-one view for each of the tables in the physical dataset, and we save them in the staging layer, right? Within these views, we can perform some data cleansing actions, such as renaming columns, changing their type, and so on. But these are only views we created. As we have the data stored in the data lake in a CSV format, what we can do is using the view of the fact table in the staging layer to use it as an anchor data set for a general purpose row reflection. And with this first reflection, we achieve having the data in an optimized format. And additionally, we can select some fields that appear in most of the common joins. Wait, because I've passed this. We can also select partitioning fields, and the table you see on the screen is what the reflection will look like when using the Dremio's UI. This reflection will improve the overall performance of the queries and even the creation of newer reflections. So it is great to start with this reflection for this specific use case. So what we're going to see in the following slides is a step-by-step guide on how to create reflections. First, we are going to see some ad hoc queries to familiarize with reflections and make sure that everyone follows the presentation. And after we have understood how we can leverage reflections to improve performance, we will focus on accelerating BI dashboards. So to start building a reflection, we must know what we are going to query beforehand. No, it's a typical thing to do when working with BI. So this study is needed to detect the partitions, the measures and dimensions that we're going to be selecting for the reflections. So then it is common that we find a query that has subqueries in it. We must focus on these first and build reflections for the subqueries, and then expand afterwards if needed. And after the previous steps, we can start creating an anchor data set, which will be the view upon which we will build the reflection. And finally, we build the reflection with the dimensions, the measures, and the partitions. So now that we can start with another query to see how this works. Here we have a query for the survey data set, which result shows all the surveys that are 5% longer than the average. And to make useful reflections, we must focus on the subqueries. The first one has a count listing operation on the field question ID. The second subquery has an average operation. And finally, we have the end of the query, which only selects fields, and there's nothing special there. So we will make 2 reflections, one for each of the previous subqueries. So let's focus on the first one for now. In the first subquery, we can see that there are two fields being used: survey ID, which is in the group by, and question ID, which appears in the count operation. With these fields, we create a view or anchor dataset, and then we save the view in the business layer, for example, with the name of question count. And finally, we build a reflection on top of it. When creating the reflection, it will contain the group by field and the distinct field as the dimensions, and the count field, which is the one used together with the distinct as the measure. And optionally, we can also select approximate count distinct if you expect to use it anytime. And in the second subquery, we can see that there is only one field being used, count questions, which is a field that comes from the previous subquery. This field is used in an average operation. That means that we repeat the process of creating a view with the used fields, and we keep this view for the second subquery in the business layer as well, and now with the name of average questions per survey. And finally, we create the reflection by choosing the only field as the measure. And this time, for calculating the average, we select sum and count. So after we have all the reflections prepared, we can execute the query and check the job history in Dremio to see that we get around 1 second of execution time for 1 billion rows, and that the job used both reflections we created to finish faster. So now that we have seen how to create a reflection to accelerate our queries, let's move on to the dashboards with Power BI. Previous to this, and as we just did with the previous example, we must understand the dataset and know the type of queries that we are going to cover with the charts. So, for example, we know that we will always be filtering by question ID to focus on a single question of the surveys, and we'll also be focusing on the proportions of the answers for each question. And in addition to that, charts will be having a filter for the rest of dimensions in the dataset. So with the following slides, we will keep things simple by focusing on one single chart. We will show the queries generated by Power BI to compute the chart and what reflections we can create to accelerate them. We will see what happens with the addition of different possible filters, and we will show execution times to be able to compare different approaches when building reflections for BI. We can now start with the dashboard. Here we see a chart with some filters around it. In this dashboard, we are calculating the proportions of the answers for a specific question, and we are dividing or grouping the result by each country. So we can guess that the dimension fields will be all the filters we are using, as well as the countries and answer levels by which we are grouping the result. But even so, we can run that visual and check the job that is created in Dremio, which is this one. Then we can create the reflection focusing on this query, right? So we can get, what we can get of this query is the key fields that are highlighted. And other than that, we can say that this query looks a bit long and complex due to the joins that Power BI needs to perform, because we are querying from 80 different tables, right? So the issue here is that this is the query from the previous chart without using any of the optional filters. If we wanted to apply some more filters to the chart, we would have a query with even more nested subqueries and more complexity, and this could be problematic. So another thing worth considering is the time it takes to run this query without any extra work, just as we have everything by now. You can see it in the top right corner of the screen. It takes 18 seconds. So let's see why having complex queries can be problematic. One of the phases that each job in Dremio has to go through is the planning phase. Here, among other things, the query is analyzed to seek a matching reflection that can accelerate it. When we have queries with high complexity, the planner might not fully check its structure and might not match the most accurate reflections in order to save time. So this is a problem for the query we just saw, because it has many levels of nested queries, and we have even more as we apply more filters. So one solution we thought of is joining all the data in a view and querying to that view from Power BI. So instead of having the 18 tables model, right? So as this join will be a view, no data is being replicated, and we can take advantage of this to lower the complexity of the query. So that's what we are going to do. We create a view that joins all the tables. We save the view in the layer we think most fits the query, and we change the data source from Power BI to target the new view. So when plotting the chart again in Power BI, we get this query sent to Dremio. It is the same chart we saw before, but now we are querying from a view that contains the data of all the tables. So we can see that we are querying from the virtual join of the dataset, of all the dataset, in the line that says from processing.allJoin. Processing is the semantic layer, and allJoin would be the name of the view. For the highlighted fields, we have the survey ID as the aggregated field, and all the other as dimensions. So we can appreciate that this query is much simpler than the one we had before, and now we can make use of reflections. So the same way we did before, we create a view to have a reflection with these fields. Then we select each of the fields as dimensions or measures. And finally, we can run the query again and check the job history in Dremio to see that the reflection is being used, as well as the time it takes to be executed. In this case, we see it takes 5 seconds to execute the query. And if we compare these 5 seconds to the previous 18 seconds, we can say that we have lowered the runtime thanks to this aggregation reflection. So although this has been successful, there is another thing to consider. If we wanted to apply some of the optional filters to the chart, for example, in the right side of this image, we can see that we have selected the age, gender, and nationality filters. So once Power BI starts the request to Dremio, we end up with a query like this. It is similar to the one we had before, but it contains more fields in the workflows. But now they are in the same subquery level. So one could think, okay, we could solve this by changing the previous reflection and adding all the possible filters as dimensions. So we would have an aggregation reflection with all the dimensions, all the 17 fields. But if we did that, Dremio would calculate each measure of the reflection for all the combinations of the dimensions. That means the reflection would take long to finish, but not only that, by putting so much data into a single reflection, we would be limiting Dremio's parallelism to resolve queries. We can check the job and see that we get the query in 23 seconds when adding the age, gender, and nationality filters, when also using the 17 dimensions reflection, and that's the slowest time we have gotten so far. So instead of this large reflection, we can keep the smaller aggregation reflection for when we do not use additional filters or when we have very few filters, but we must avoid using an aggregation reflection with so many different values because what makes an aggregation reflection worse in performance is having high cardinality fields as dimensions or simply having lots of dimensions. So if we run this query again without using this last giant aggregation reflection, we will see that the raw reflection we created at the beginning is covering the query, right? So we can see that it lasts 8 seconds and that the reflection being used is the general purpose one, the one we started with, together with all the one-to-one reflections targeting each table of the dataset. And there is more to this. If we go deeper into the details of a job in Dremio and see how it was planned, here we have the plan for the job of the aggregation reflection with all the dimensions fields. It is a single thread of tasks. This is for the same part with the same filters. The only difference is that we use the giant aggregation reflection, the one that contains all the dimensions and took 23 seconds. So in contrast, we have the job for the last approach, the one that runs the same query, but with no aggregation reflection. Here we see that Dremio plans it with a multiple thread of tasks. And it uses all the one-to-one raw reflections from the staging layer. And this task is the one that took 8 seconds to finish. So we have seen that there are some things to consider before creating reflections, and we cannot just start creating them without previously planning, right? So let's finish with a summary of the key points we have just seen to consolidate what we have learned from this use case with Dremio. The most general things to keep in mind are related to the use of the right architecture for your data. Things like separating compute and storage are healthy practices that are being applied nowadays. By doing this, you can scale each of these independently, and often it leads to reusable structures that do not rely on specific services, right? Dremio is a perfect example for that, as it works directly with a data lake, but remains isolated when it comes to scaling to allow that cost-effective scalability and compute. Another great thing is that it is not tied to any specific provider. As Oscar mentioned, you can build Dremio in different clouds, even on-premise, using different data lakes as the data source and connecting it to a wide variety of BI tools. And regarding the most technical concepts, here are the main points we think you should remember. Row and aggregation reflections have different purposes. None of them is better than the other. Row reflections, though, are a must when we do not have the data stored in an optimized format. And as for the aggregation reflection, we should avoid using one single reflection for all the possible dimensions. Okay, it offers better performance to have small reflections. We have seen that using the first row reflection offers lower execution time than using the giant aggregation reflection with all the dimensions in it. But also beware with having a lot of reflections that perform similar calculations, because that may cause the planning phase of the query last longer. That happens because the matching of the queries with reflections is held during this planning phase, and having more possibilities to analyze means more time to find the most suitable one. And the last thing, we have seen a useful way to prepare data to lower query complexity by joining it in a single view. This will make all the filters be applied in the same subquery level from the BI tool, and will ease the development with reflections and their detection by the planner. Okay, so here ends our presentation.